So in the previous session, we have talked about classification of gear. I just give you a short review. We have talked about different types of gearing based on the, you can say, meshing, their internal, external, brake and pinion, or according to the position of axis that we have discussed in helical gear. So in this session, I will take you further beyond helical gearing. So look at this here, the helical gears are meshing. So you see the contact in this slide is explained from the beginning of engagement would happen at the extreme left, and as the gear proceeds or rather meshes further, then this section moves towards right. So at the same time, in the last this thing I have talked about uh, axial thrust. So that axial thrust can be demonstrated with the help of an experimental setup. So just see how that axial thrust plays a vital role in case of gearing. So in this video you can see the setup. You have one spring which is attached with the shaft of the gear, and the gear can also slide along the axis of the rotation. So you can say this spring getting compressed, and you see why this is getting compressed, because there is some force must be coming in that direction, and therefore we call it there is axial thrust comes in picture while the helical gears are meshing. Now if somebody want to go in much details about that, then for that we have this slide over here. So in this slide you can find there is a force component which is coming. So in this slide we can see the force which is acting on the teeth, or rather the force which is passing through line of action. So that force we can call it as a Fn. So this force we can see we have drawn a cuboid, and the force is diagonal to this cuboid. So now if we can resolve this force Fn in different components, so one component of force comes like this, and this component we call as a radial force. And if we can take other component of this Fn on this direction, or rather in the tangential direction Fn, so this component in the tangential direction is known as your tangential force will lead to give the torque to the gear, and because of that gear is rotating. And the last part of this is your Fa. So this Fa is important component, and this Fa acts in a axial direction, and therefore this force is your axial force, and which we are more interested in. So in nutshell, if we can say in case of helical gear, because of the type of the teeth with the helical gear have, because their teeth are inclined by an angle psi with the axis of rotation. Therefore, the normal force on the contact point is Fn, and that normal force at the contact point can be resolved into three components, and out of these three components, one component is in the axial direction. So whenever two helical gears are meshing, there will be a axial force because of the result of their meshing. Now, if you move further, that how we can overcome this problem. So there is a solution is also there. To overcome this problem, we can use pair of helical gears, or you may say there are two different helical gears which are having different helix angle. One is having left hand helix, and other one is having right hand helix, and these two gears are put together and then they are used. So this combination is called herringbone gear. Why the name herringbone? Because of the name of the fish, and the spine of the fish is in the form of this profile or this shape. Therefore, it is called as herringbone gears. So if you look at these herringbone gears during meshing, so what happened? one gear producing axial thrust in one direction, let's say one normal force is creating axial thrust in this direction, then other normal force which is creating thrust in this direction. So these two force become equal and opposite and they get cancelled out. So therefore, to avoid this helical, this axial thrust, you can use this sort of combination. So again, look at here, to avoid axial thrust, two helical gears of the opposite hand can be mounted side by side to cancel resulting thrust. So you can see the arrow which I have shown, this is the direction of normal force, and now I can make another arrow over here. So this arrow is basically showing the direction of axial thrust, and in this case the direction of axial thrust is like this. So these two axial thrusts, this one and this one, mutually get cancelled out. So therefore it is herringbone gears. Here you can avoid this thing. Now another category of gearing where the two shafts are non-parallel but they are intersecting at certain angle. So if we talk about their kinematics, then we can say that kinematically the motion between the two intersecting shafts is equivalent to the rolling of two cones, assuming no slipping. So when the two cones are rolling without any slipping, they can transmit motion from one cone to another. And that is the kinematic involved when we talk about gears which are used to join two shafts which are intersecting but non-parallel. So the gear in general are called as the bevel gears. So you look at this bevel gears. Now in the bevel gears you have further different categories. So we'll talk about straight bevel gears. In this case the teeth are straight radial to a point of intersection of one shaft axis and they can vary in cross section throughout their length. So you can see the cross section of the gear teeth are varying from the, you can say, the leading point to the last point. Then in the straight bevel gear, there is another category which is called the meter gears. So in meter gears is a special case of bevel gears where the number of teeth on the two different gears are same and they can be positioned in such a way that they can transmit power from one shaft which is placed like this. Let's say one shaft is like this, so another shaft can be placed like that so that they can transmit power at 90 degree. So therefore it is written the shafts are positioned at right angles from each other and the gears have matching pitch surfaces and angles with a conical shaped surface, right? So in case of meter gears, you can have the ratio of velocity ratio is 1:1 because both are of the same size. Because of same size, the RPM is same. So look at this animation where you can get the feel of how bevel gears are meshing with each other. Then another category is called spiral bevel gears, where the gear teeth are not straight. However, the gear teeth are curved in the way which is shown in the picture. So look at this. This is nothing but your differential of a car. When the car is moving on a straight path, then there is no movement of the two pinions which are there. And when there is no movement of the pinion, then there is no differential motion at two different, you can say the shafts or axles. Wherever we'll take turns at that time, the pinion which is inserted between the two, you can say the bevel gears, this also start rotating about their own axis. And when it start rotating their own axis, then there is a differential velocity comes at these gears, at these gears. So these gears will start rotating at different speeds, and then you can see the wheel which is at the outer end, or you can say other end of this, when the vehicle is taking turn, outer wheel will move faster as compared to the inner wheel, because inner wheel is closer to the radius of curvature. Therefore, it needs to cover lesser distance, and the outer wheel has to cover larger distance. Therefore, this gear, I can say the gear 2 will move faster compared to the gear 1, and at the same time you should remember at that point this gear will start rotating about their own axis, this small pinion. Again I am pointing out this gear will start rotating about their own axis, otherwise it is acting as a key when the vehicle is moving on a straight road. Then next category is skew shaft. Skew shafts, when these shafts are neither parallel and non-intersecting, but here you need to transfer uniform rotary motion by pure rolling contact. So non-parallel, non-intersecting shafts. So this is very important application where you can find the worm and worm wheel which is used to transmit bar. So in this, what happened? You can visualize if you can rotate this worm at single turn, then what happened? Your worm wheel will rotate one by number of teeth on the worm wheel. So this is very important to understand that it can give very large speed reduction